Hello children, today we will discuss the chapter 10, that is light, reflection and refraction. So in this chapter we are going to cover the following topics, that is light, reflection of light, laws of reflection, and the last topic is spherical mirrors. So here we have two types of spherical mirrors. One of them is concave and the another one is convex. So let us discuss these above mentioned topics. So let's move on to the next slide. Here the first topic which we are going to discuss, that is light. So light means it's a source of energy that produces the sensation of sight, so we can see the object around us. So the process is very simple. First of all, the light falls on the object, gets reflected back from the object, then enters into our eyes and it forms the inverted image on the retina. So this is all about the light. Make note of it also in your notebook. Reflection of light, it is very simple process in which a ray of light falls on the reflecting surface and then it is sent back to the different direction but in the same medium, is called reflection of light. So let's discuss with the help of this diagram. This ray of light falls on the plane mirror. This is the plane mirror, and a ray which falls at this point on the plane mirror is called, this is incident ray, and this point wherever it fell, that is called as point of incidence. Now this is the perpendicular, so draw a perpendicular to the point of incidence. This perpendicular is called normal, and after the reflection the light gets reflected back in the another direction but in the same medium. This is called reflected ray. So in this case this is incident ray, and when incident ray makes an angle with normal, this angle is called angle of incidence. On the other side, reflected ray makes an angle with the normal, which is called as the angle of reflection, and the perpendicular to the point of incidence is called as the normal. So now let us discuss. There are two types of there are the two laws of reflection. The first one is incident ray to the point of incidence, normal to the point of incidence, and the reflected ray. All these three lie at the same plane and at the same point. This is the first law of reflection of light. The second law, as it is very clear from the diagram, that is angle I is equal to angle R. So that means the angle of incidence is equal to angle of reflection. So this is the second law. Now let us discuss these laws. These laws you can make a note in your notebook. So for that purpose we are giving you here. Now after this is the first law and this is the second law. Now let us discuss about the plane mirror and the properties of the plane mirror. So plane mirror is a reflecting surface and it always forms the virtual and the erect image. It forms virtual and erect image, and then also it forms the image, and the image which is formed by it is of the equal size as the size of the object, and the distance of the image as well as the object from the mirror is also equal. So these are the following properties of the mirror. Now come back to, we have the spherical mirrors. So actually the spherical mirror is a mirror whose reflecting surfaces are spherical, are called as the spherical mirrors. So we have now the two types of the spherical mirror. One is called as the concave mirror and the second one is called as the convex mirror. Now come back to what do you mean by the concave mirror. So it's very simple. Let us discuss about the reflecting surface of a mirror, right? And that reflecting surface of the mirror, if it is curved inwards or it may be curved outwards. So a mirror whose reflecting surface is curved inwards is called as the concave mirror, and the other one whose reflecting surface is curved outward is called as the convex mirror. So I'll show you with the help of the diagram. Now let us focus on this one. The solid line here represents the reflecting surface. So if the reflecting surface of the mirror is curved inward, right, so this is called as the concave mirror, and in this case the reflecting surface is curved outward, and that's why it is called as the convex mirror. Now let us discuss the concave mirror and its properties in detail. So just focus on this diagram. This mirror which I have taken here, it shows the concave mirror. And why it is called concave mirror? Because this mirror has got two surfaces. One surface, this is which is represented by the solid line. This surface is the reflecting surface, and the another surface is the rough surface. So this mirror has got two surfaces. This one is reflecting one and another one is the rough surface. Most of the reflection of the light is taking place on this reflecting surface, and this mirror is called as the concave mirror because its reflecting surface is reflecting inwards, so it is curved inwards, or we can say that it looks like a cave. That's why it's called concave mirror. Now let's focus on this point P, which is the center of this concave mirror. So the center of the reflecting surface of this spherical mirror, which is the concave mirror, is called the pole of the mirror. Now another one, if you see, draw a straight line like this. This is a straight line. If you draw the straight line which passes through the pole of the mirror, actually it is a special straight line. There are other straight lines also above it and below it, but these are not called as the principal axis. But this is a special straight line which passes through the center of the mirror, which is the pole of the mirror, is called as the principal axis. Another point is very interesting, that is the principal focus, or point which lies on the principal axis, because this straight line is called principal axis, and the point which lies on the principal axis where all rays of light after the reflection they meet at this point. For example, let us consider ray 1 and ray 2. So ray 1 goes, hits the mirror, gets reflected from the mirror, and then it meets at this point F. Similarly, the second ray also goes here, gets reflected and meets at a point F. Also below this line, this is principal axis, and below this line there are two rays. Similarly, these two rays are going towards the mirror. After the reflection, they also meet at this point. So after the reflections, all these rays are meeting at a point, and this point is lying on the principal axis, is called as the principal focus of the concave mirror. Another interesting point, that is the center of curvature. Center of curvature is the center of the hollow sphere. So now here focus more on what is the meaning of hollow sphere. For example, if you take, this is the part of the reflecting surface. So this part of the reflecting surface, and if you extend it, then you form a full sphere. So this is a full hollow sphere made up of the glass, from where we have taken this small part of the reflecting surface. So when you explain students the center of curvature, so center of curvature means it is the center of the hollow sphere of which this reflecting surface of the mirror forms a part of the sphere, is called center of the curvature, or in short you can say it is a center of the sphere of which this small part of the mirror is the concave mirror, is called center of curvature. Now let us discuss the measurements or the distances which we can measure from the point P. So the distance between point F, which is the principal focus, and the point P, so this distance is called focal length. Another distance which is very interesting, that is the distance of the center of curvature from the pole, is called as radius of curvature. So this distance is C from, that is the P, this distance is called as the radius of curvature, and the radius of curvature is 2 times of the focal length, because this is the focal length from P to F, this is the focal length, and this distance is also equal to the CF. So focal length 1, this is 2 times of the focal length, it means the CP, which is the radius of curvature, is also equal to the 2 times of the focal length. Another interesting point you must note down here, any ray which you draw, like any line which you draw from the center of the curvature towards the point on this at a point on the surface, it acts as a normal. So this C which I'm showing you in the diagram, this C, and at between the point M and the C, this acts as a normal. This is all about the concave mirror. Now let us discuss about the convex mirror. In case of convex mirror, we have the few points like whatever I discussed now. There's a pole. Pole means the center of the mirror. Here also the center of the mirror is called as the pole. But in this case, in case of convex mirror, the surface, this is the reflecting surface which is reflecting, which is curved outwards. So that's why it is called as the convex mirror. This solid line is representing reflecting surface which is curved outward, and the other surface is rough surface. Now in this case, the maximum reflection also takes place on this reflecting surface which is curved outward. But interesting thing about this diagram is all the rays after the reflection from this reflecting surface, they actually do not meet at the point F. They actually appear to come from the point F. Now let us understand how. For example, consider this first ray. First ray is moving towards the mirror. It gets reflected, but after the reflection, this is the point of incidence where it fell. So from the point of incidence, you draw the dotted line which meets a point F. But actually, if you consider, if you look at from this side, so this ray is appearing, actually it is not meeting at point 1, but if you look at from this side, you feel that this ray is coming from the point F. So this is the formation of the virtual image, and the virtual image is erect image, you can say, and it is formed on the right side of the mirror. This is the left side of the mirror, this is the right side of the mirror. And this mirror is also called as the diverging mirror because it diverges the rays of light after the reflection from its reflecting surface. So this is the diverging mirror. Thank you.